Folks, where we are going to be starting today is just kind of outlining the parts of the term review. So, yes, this says non-calculator. Am I going to restrict your calculator on the test?
Yeah.
No. No. This is just the sorts of things that I would expect you to be able to do without a calculator, especially going into Calc 1. So, no, I'm not going to restrict your calculator use at all, but that's why this term pack is kind of out of order. As a reminder, not due. This is just for studying. We're going to outline what problems correspond to what units. This entire first page is Unit 4.
Oh, so is the test going to do the same?
No, test is going to be chronological. This is just split up awkwardly because of the non-calculator.
Unit 1 problems and then Unit 2 and then Unit 3.
Yep, Unit 1, Unit 2. Yep. Alrighty, page 2. This is Unit 3. So Unit 3 for page 2. Page 3, Unit 5. Which is our current unit. Turn the page. We've got a few things to change on this page. This is Unit 4. However, it does contain the tail end of Unit 5 in here, which we haven't gotten to yet. So we're only going to be doing parts of some of these problems. You're going to do part A, and I want you to state the domain of that function. And find the vertical asymptotes, the horizontal asymptotes, and the x values of the holes. Slant asymptotes, x-intercepts, y-intercepts, those are out. Problem B, we're going to straight up change that equation to be f of x equals 2x over x squared plus 3x. I want you to state the domain for that one as well. Same 3 boxes. And then problem C, you can skip entirely. Problem 3, out. Everybody good on that page? All right, next page. This is where your calculator goes active, which means you're probably going to have to use your calculator on these problems. These are Unit 4. And we're not going to go through all these problems over the next few days, but if you want extra practice with something, the solutions are posted on good old Canvas. On page 6, that's Unit 2. Hooray for conic sections. Next page, Unit 1. And then the back page, number 15 is crossed off, so that is a legit X. And number 14 is Unit 4. So our goal is to get through 1 and 2 today, which means on the My Math Lab review, you should be able to do all the way through 18. That helps you. I think 1 through 9 is Unit 1, and 10 through 18, I think, is all conic sections. Alrighty, folks. So we are going to be starting with Unit 1, which is on page 7. And we're going to begin with solving a system of equations. First, if I want to solve a system, what am I looking for? X and
Get a variable by itself.
X and Y. And substitution is when we get a variable by itself. Excellent. So when we are solving a system, we are looking for the intersection point and or points. So the intersection of whatever the two functions are. If they are linear systems, you can use elimination or substitution. If it is a nonlinear system, you have to use substitution. Nonlinear, must use. You can also solve with your calculator. So if it says solve graphically, that means use your calculator. And this is important for some of the grosser nonlinear systems where you would get decimals or you'd have to use the quadratic formula. So we're going to go over on how we can solve graphically using our calculator. Now you'll notice on problem A, we have a nonlinear system because the first equation is a quadratic. Second equation is a line, but as a whole, it is a nonlinear system. So on the MyMathLab term review, on number 3, it says solve algebraically. So what this means is you might be able to check using your graphing calculator, but as far as the work page goes, I have to see your algebraic solve work. So remember on the test, you get points separately for just the work, trying to do the right thing, and then you get a point on the MyMathLab itself for actually getting the right answer. So if you're like, I can't do it algebraically, but I know how to get the right answer on my calculator, you would get the point on MyMathLab, but you would lose a point on the work page. Does that make sense? So that's kind of why I wanted to provide you with this, and if you have any questions about that, please let me know. But again, these are just the instructions. You'll probably need extra scratch paper to actually show work on those. So we're going to go ahead and look at problem A, and we are going to solve it algebraically. So actually, let's write that up here. So solve algebraically. And since this is nonlinear, we have to do substitution. So let's go ahead and try to isolate our easiest variable. Y is already by itself in the first equation, but since I'm going to be checking myself on my calculator, I'm going to go ahead and isolate y in the second equation as well. So we subtract x, and we get y equals negative x plus 1, or 1 minus x. So substitution says if I have a variable equal to stuff, we're going to take that stuff and plug it in for that variable in the other equation. So negative x plus 1 in for the y in equation 1, and then is equal to x squared plus 2x plus 1. So now our equation is all in terms of x. How are we going to solve from here? Set it equal to 0, thank you. So we've got a quadratic, and that makes me think I'd sure like to try to factor it, but before we can factor it, we need to get it set up so we can use the zero product property. So we're going to go ahead and add x and subtract 1. And that gives me 0 equals x squared plus 3x. How are we going to factor that? GCF. So first thing you always check for when you're factoring is a GCF, and our GCF here is x. Setting each of those equal to 0, we get x equals 0, x plus 3 equals 0, x equals negative 3. But unfortunately, we aren't done. Why are we not done? We have to find the corresponding y values that go with it. So this is a little bit different because with polynomials, We've been trying to find the x-intercepts where y is 0, but in this system, we need to find the corresponding y value that goes with those x values. So we're going to take these and plug them back into, I would say, the isolated y equation. So negative 0 plus 1 is 1 for the y. And then negative 3 is 3, plus 1 is 4. So on MyMathLab, you would write these as coordinates separated by commas. Oh, comma. I'm going to be giving you guidelines on here also about where to find things in your notes. This would be notes, page 3. So if you need extra help with nonlinear systems, this is where you will go. So folks, my goal for this, since I crunched numbers in the last block, if you're sitting at an A and you get a 0% on the final, what do you think that lowers your grade to? I'm just curious.
B.
Just a straight B. So if you get a 0%, it lowers you to a B. So does that make us feel better? No? Are any of you guys going to get a 0%? I think you'd have to try really hard to get a 0%. I mean, don't test me, but so my goal for this is to help prepare you for college finals when maybe the weight is a little bit heavier. Your water bottle's right over here. Yep, it's over there. My goal is to show you guys how to study. So we've taken great notes. We have this packet that behaves like our textbook for this course. In college, you're going to either be highlighting and marking up your own textbook or taking your own notes, putting post-it notes everywhere. So as I'm looking, hey, nonlinear systems, there they are. Here's the helpful things that we have highlighted and said to be careful about. So we're going to be going over the basics, but as you are working on the MyMathLab term review, this is a great place to look for things. If you're stuck or if you're not sure where to look for things, please email me or come in before or after school to ask questions. But this is where you can find a lot more on nonlinear systems. What I am going to demonstrate is how we can check ourselves graphically. We will go to the y equals, type in our equations, second trace, and then intersect. But you'll find the specific nuances to that in your notes. So we go to the y equals. Go ahead and just watch up here. I'm just going to demonstrate it. I typed in both of my equations, so notice they both have to be solved for y. So if you have a y squared, square root, you're going to have to put the positive version of the equation in one slot, negative version of the equation in the other slot. When I hit graph, there they are. And we can see that we have two intersection points. So second trace, intersect, enter once for the first curve, enter twice for the second curve. For the guess, I'm already sitting at that point. I'm just going to press enter. And we see negative 3, 4 is definitely a solution. Now, if I want to find the other point, I repeat that process. First curve, enter. Second curve, enter. Guess, we're going to hover closer to the other point. And it tells me the intersection is 0, 1. If you are using one of the older calculators where it's tougher to tell which curve you're on because it doesn't have the colors on it, you can borrow one of mine during the test. Questions? Do we remember doing this? Yeah. Good for you. That was so long ago, like the first and second week of school. All right, folks, elimination, Gaussian elimination. This is on page 4 of your Unit 1 notes. Gaussian elimination, we eliminate, we get our A and B equations, we eliminate again. You can check using reduced row echelon form on calculator. So again, folks, there are some problems that I'm going to be looking for specific work, but don't forget your other methods of solving if you can't figure out how to make the work on checking your answer or verifying your answer to make sure you have done it correctly. So Gaussian, you can look up on page 4 of your notes. 13. Oh, here we go. Are we ready? Row echelon form, your favorite thing ever. On these problems, we are going to have to show the row operations. I will demonstrate how we can check ourselves using reduced row echelon form on the calculator. But on an REF problem, this is going to be work that I am looking for. So the first thing that we want to do with this problem is turn it into an augmented matrix. So in an augmented matrix, every equation represents a row. So 3 rows. Anyone remember how many columns we're going to have? 1 for the x, 1 for the y, 1 for the z, and 1 for the constant. So 4 columns. Leave enough space above your matrix to show any row operations. And we are going to be putting in the coefficients of our variables. So the x column will have 1, -2, 2. What are we going to put in the y slot? 0. And then 1, 1. For the z, -1, 3, -1. You can do the little dash line to separate your constants if you wish. 2, -5, 3. And after I write my augmented matrix, it's always a good idea to check yourself and make sure you haven't missed a sign anywhere. Because if your augmented matrix is wrong, obviously the rest of the problem is going to be pretty terrible. So folks, row echelon form works similarly to get. We're essentially trying to eliminate the x variable twice to get us a 2 variable set of equations, and then eliminate those, getting rid of the y, to take it all the way down to a z equation. So what that looks like row echelon form wise is we want a 1 in the top left position. What do we want below the 1? 0's below. Wonderful. Now, how are we going to get those zeros below? If it helps, you can think what you would do elimination-wise to get rid of your x's. So what could I do to row 1 so that when I add it to row 2, it cancels?
2 times 2.
Times it by 2. So what row are we replacing? Row 2. What are we replacing it with? 2 times row 1 plus row 2. And now I'm going to show that work. 2 times row 1. 2 times 1 is 2. 2 times 0 is 0. 2 times -1 is -2. And 2 times 2 is 4. In my next matrix over of work, I'm going to add that new pink row of work to my row 2. So 2 plus -2, 0. 0 plus 1, 1. -2 plus 3, 1. 4, -5, -1. Questions so far? For getting the 0 here, this next 2 to be a 0, we could multiply row 1 by -2, or what else could we do?
Row 3.
Row 3 plus row 2. So what row are we replacing? Row 3. What are we replacing it with? Row 2 plus row 3. So I'm going to add those terms together. So -2 and 2 is 0. 1 and 1 is 2. 3 and -1 is 2. And then -2 for the last one. And what about row 1? It just stays the same. It's all good with that 1 in the top left position. So now we have our first column of row echelon form done. And again, why did we do this? We eliminated our x variable twice. So now we have a YZ equation in pink and a YZ equation in blue. So our next goal is to get a 1 slanted down and a 0 below. So we're going to eliminate our y variable so that we get just a z equation. Row 1, remember, is off limits after the first column because it would ruin the integrity of those zeros. So what can I do to row 2? We're going to replace row 3. And what are we going to replace it with? Negative 2 times row 2 plus row 3. So negative 2 times row 2 would be 0, negative 2, negative 2, and 2. So what happens next? 0 and 0 and 0 and 0. Uh-oh. We didn't do anything wrong, but our row echelon form is a special case. What does getting that entire row of zeros tell me? I thought I heard someone say it. It's infinitely many solutions. So my variables all canceled and I got a true statement, 0 equals 0. So this is going to be IMS. But remember, we're pre-calc students, so we don't just get to stop at IMS. We get to come up with a coordinate solution formula that describes all of the coordinates that will work in this system. So to do this, which variable got eliminated if we think about the columns? Z. So since Z got eliminated, Z is going to be our reference variable. So in our coordinate solution formula, we're going to have Z in the Z slot. And our goal is to get an expression for Y and for X, all in terms of that reference variable Z. How do we do that? We're going to turn these rows back into equations by using the corresponding variables and coefficients. This says 0x plus 1y plus 1z equals -1. How do I change this to be an expression for y in terms of z? Subtract that z over, so minus the z, and we get y equals -z minus 1. An expression for y in terms of our reference variable. So I'm going to put that in the y slot. Probably should have gave myself a little bit more room in this coordinate. So -1, -z. So to get an expression for x in terms of my reference variable, we do the same thing. We turn this row back into an equation with variables. So 1x plus 0y minus z equals 2. So to get an expression for x in terms of z, we're going to add that z over so that x equals z plus 2. An expression for x in terms of z, and that's what goes in my last slide. And that is my nasty coordinate solution formula. Do we remember doing these? Awesome. Do we have any questions on any of these steps that we did along the way? All right, so what I'm going to demonstrate next is how to do this on your calculator, checking using reduced row echelon form. Up by that section, I want you to put those instructions for reduced row echelon form are on page 11. So page 11 is where you'll see the calculator steps. So I'm going to briefly go through them here, but if you want to see them written out step by step, there's like 6 steps
So we got calculator.
for how to use the calculator to do reduced row echelon form. So here's the page in your notes. Those are those steps we did. So I'm just going to go through it quickly to remind you of a few things. We first access the matrix area of your calculator, which we do using second x to the negative 1. We use the tabs up at the top, names, math, and edit. We go to the edit tab to type in the dimensions of the matrix, which I already have in there. Then we quit doing second mode to get us to the home screen. Second x to the negative 1 to go back to the matrix. Math, reduce row echelon form. And remember, we don't want to use REF because 90% of the time it's not going to be the same as our actual row echelon form matrix. Reduced row echelon form checks the answer. We select that operator, go back to the matrix, and select the name of the matrix. And that gives us the solution, which is 0 equals 0, or IMS. So I would still have to change that matrix into the equation solutions, but this would at least be a way for me to check myself to make sure that matrix and those solutions are correct. Folks, that's a wrap on Unit 1. Do we have any questions so far?
Are we not doing number 2 Gaussian at all?
Gaussian is on page 4.
What were you doing testing?
I think there is a My Math Lab question on it. So Gaussian on page 4, this is just where you eliminate the same variable twice. So again, when you look in your notes, you'll see the more detailed instructions. So I'm mainly going to be hitting the harder things, which is going to come into play with conic sections. So any questions on the Unit 1 stuff? Do we want to take a quick breather before we do Unit 2? Okay, breather time, let's go.